About the syllabus, you can see here, this document is there. I could download it and print it, or you could download it and print it. Or if you don't think you need it in paper, I think, why do we need all that paper? Right? It's there. There's a description of the course. This is a new course. This course only started last semester, and we have tweaked it a little bit. That is, we changed a couple of things in it just to make it so that we can get a better success at it. We did have a lot of, did have people find it a bit hard. So I'm going to make extra effort so it's not too hard for you. We'll see. There's a few things that that are mentioned here that this is kind of like almost like a legal document. This is what we promise you. So this is like a contract, right? This is what we promise you. We will try to sort of present to you, and it's up to you to make the other side of that promise to actually learn it, right? But we will promise that we'll give you the opportunities to learn these things. How to write a program. What are some other things here? Yeah, this is all about programming stuff. Computational thinking, which is thinking in a way so that you could solve a problem using a computer. That would be computational thinking. It's not being a computer, it's thinking in a way so that you could construct a problem in such a way that a computer can be used to solve that problem for you. If you can do that, then you don't have to be a computer programmer, but certainly you'd have to be able to do that to be a computer programmer. But you could also use those skills in lots of other things. Algorithms, there's a big word. Algorithms just means sort of step-by-step instructions that we give to write a program. Here's the simplest algorithm you ever heard of, is a recipe. When you have a recipe to cook something, that's an algorithm, right? Because you do things in a certain order, and then you get some food. That's an algorithm. So an algorithm doesn't have to be on a computer. And then so we try and explain here how our assessment works with the things that we want you to do. You'll see there's some assessments there. I've got a summary of the assessments at the bottom, just so it's very clear that you know how we're going to assess you so that you're graded. You know that you have to get 60% in this course to pass. So how that's going to happen is there's going to be a 30% exam in April. And then there's going to be 2 tests before April. One's going to be in week 5, and one's going to be in week 10, I think, or something like that, maybe 11, but week 5 for the first one. And they're going to be 20% each. So the tests are big. They're almost as big as the final, right? And together, all of that 70%. Then we divide up the remaining 30% among these other 3 things that we're doing every day almost. So like every day not every day, but every week we will have like an assignment or a quiz, one or the other. And we'll have labs every week. And the labs, you kind of have to do them yourself. Sorry about that. We have to do things the same as every other section. So we're section 19. There's 19 sections. Well, it's not 19 sections because you know you're also section 20, right? You're in section 19 and 20 because section 19 is for the lecture and the tutorial, and section 20 is for the lab. Now they divided that up because we're moving to a university model, and in a university model we could have 2 different people doing different parts of the course. So you could have a lecturer doing what I'm doing now, and then you could have a lab instructor that would take you through the lab. Now, in this case, the lecturer and the lab instructor are the same person. And so what's going to happen is I'm only in D2L, I'm only going to use 1. So you can forget about section 20. I'm not going to do anything in there on D2L, all right? Everything will be in section 19, just so that you don't get lost. All right, so I mean, what I would hate to have happen is some student, you know, looking on section 19 on D2L, and I put a quiz on section 20 and they missed it. You know what I mean? That would be really bad. And so we'll put everything in the one place so you don't miss it. Okay, it'll all be on section 19 like it is now. I'll just make sure not to put anything on 20. So if you look there, you'll say, oh, there's nothing there. Well, that's right. That's the way I want it to be so that you won't get confused. And so there's the course. There's 15 weeks in it. When we get to the end there, recursive functions, all right? So that's That's full on computing. All right. By the time we got to there, we're doing some writing little programs of recursive functions. That's full on computing for a full on first semester programming course. If you can do that, you're doing okay. That's actually a little bit more than we asked students to do last semester. What I mean by that is last semester we didn't get that far. And so this semester we plan to. Lists and operations. So when you got to there, we're finished. There are some rules. Okay, so there's one rule there that's kind of different than we've had before. And I'll just mention it briefly. You need to have available to you a computer on which you can install software. So that's what it means by the full administrative rights. It's quite possible that we would sit in a room which is what we call a production environment. The production environments are controlled by IT department, not by IT teachers, by IT department. We don't have the admin rights to install software in the production room. I suspect that this is a production room. I'm not sure. I haven't checked the computers, but if it's a production room, it means you can't install software. You need to have to do this course properly. You need to install the software to write Python programs. We use an IDE, a development environment that's called IDLE. And so we can use IDLE to write Python programs. You'll need to do that. It's free. You just download it from the internet. It's not pirated. It's just free. It's what we call open source, right? It's free to everybody in the world. So you'll download that and you'll develop in Python. So you need to have a computer available to you that you can do that. Now, if you really don't have a laptop, well, you need to talk to somebody. You need to get one, I think, because you need to work at home too, right? Or have a desktop at least. So you need to have a computer that you can install stuff on. You got to do your own work. So when we do the labs, I will come around and help you to do the labs, but you're not supposed to share with other people. All right. So that's got to be your own. You'll see this is all in the rules, and I'll ask you to sort of read those rules. When we come to the test quizzes, so the quizzes and the tests will be different in the way that they're administered. The quizzes will be open. That means you can use your notes to do the quizzes. The tests, no. The tests will be implementing lockdown browser and also in the final exam. So in those cases, you won't be able to use anything. But the quizzes will be like every other week, and you'll be able to use your notes. But of course, you can't help each other. Sorry about that. Everything's got to be your own work there. Oh, there's my timetable in case you want. The reason why I'm showing you that is you'll see that there's lots of open spaces in there. If I have come to work to be here for this class here, that means that I'm probably going to be around the college, but for sure I'm going to try and be in my office where they got the blue thing, right? I shall try and be there, so that I should try and not be too rude to you when you come and knock on the door and say, can I talk to you? I'll try and say, yeah, okay. I'll try. No, I will. Don't worry, I will. I've never heard a student. So, yeah, you're welcome. Oh, so another thing on communication, what I usually say to students, and I know everybody does this anyways, go ahead and make a WhatsApp group for the class. I encourage you to do that. And if somebody takes control of that group and you don't mind me being in it, I will join it. Maybe you want to have two, maybe have one WhatsApp group that I'm not part of and one that I am. But if you ask me to join your WhatsApp group, I will join. And then if you ask a question, I'll answer it there. Then I only have to answer it once because everybody gets to see it, right? Wouldn't that be good? And the other thing is I will sort of make a little promise to you. If you do that, you won't have to wait for hours and hours for an answer. If I see it come up on my WhatsApp, I answer it more or less as quickly as I can. So I think students have found that to be helpful. So I'll try and do that with you. I certainly won't be waiting a day or anything like that for an answer, right? I mean, if I see it, I'll answer it. Now, if I'm watching Yellowstone or something like that, you might have to wait an hour or so till a good bit's gone. All right, so that's that. Other stuff that's on there I think we just got that started. Let's start with our first lecture, I suppose. So First lecture is history of computing. We're going to dive into that straight away. So any questions first? Okay, you kind of know how the course is going to go. You do have a final exam. Got that to look forward to, 2 big tests and a bunch of quizzes and some labs and stuff like that. All right, so let's go looking at this. Now, all of this is on there. And when I say on there being D2L, I'm actually working on D2L. You should have access to this, so you can work through this. The other thing is, as I said, I'm recording this now, and I will put a link so that you can look at this later if you're interested. Now, so I recommend if you look at it later, maybe you can change the speed, because otherwise it might be boring and listening to it twice. I think you can listen to it a bit faster. History of computing. So what we've got here is showing some going back in time. I don't know if you can see that. Maybe I can make that a bit bigger. Yeah, there we go. So going back in time, using various mechanical devices to do computing. The first one mentioned there, 3,000 years ago, abacus. And according to the notes, it's the Greeks. Not really aware of that, but the slide rule, believe me, and 1971, I was using a slide rule. So according to this, that was invented in like 1600, in the 17th century, you know. What's that, like 300 something years ago, right? But I was using one only 50 years ago. So we still had them. It was a very nice way of doing calculations. Until my first year of university, I went to the university bookshop, and there they had a calculator, a Casio calculator. I thought, wow, look at that. Look at that. I don't have to use a slide rule anymore. I just punch in some numbers and wow. Anyway, so yeah, slide rules were the deal for a few hundred years. We used to also have these tables of logs. I don't know if you've ever seen any of those, but logs, tangents, cosines of various functions. That's how we used to do math. So other people, Babbage, he used a mechanical device for computing. So when I say mechanical, there's no electronics in it, right? All it was sort of gears and stuff, and you'll see some images of this. So a couple hundred years ago, they're using computer machines that are not electronic. Hollerith, we'll talk about Hollerith later. Hollerith solved a problem for the US government, which was counting how many people there are. We call that a census. It used to take them like 10 years to add up all the numbers. And then Hollerith was able to do it, I think, in 1 year. Still sounds like a long time, doesn't it? Then the transistor radio, very important. The space race really was related to the transistor radio, or the transistor radio related to the space race. Transistor radio and integrated circuits, because the problem is sticking stuff up into space. It takes a huge amount of energy just to get a kilo of stuff into space. So if you got a ton computer and you can make it smaller, that's a really, really good idea. And it's going to save you a lot of rocket fuel. And so, but the benefit of that is that those transistors can be used for lots of other things, like radios, TVs, and integrated circuits could be used to make personal computers and mobile phones. Go figure, right? So something good came out of the space race. Then we know some more modern history. A lot of people got really, really rich out of computing things, right? And one of those people was Steve Jobs, who he and his partner sort of developed the Mac computer. And the genius of the Mac computer was the graphical user interface. The graphical user interface meant that you didn't just have to type everything out in this boring sort of interface. The boring interface that I'm talking about, command? Yeah, there we go, command prompt. This is how we used to do computing. It was all like that when I started doing computing, you know. We'd have dumb little commands like that, dir, which is show me what is your, some of you might do some networking, and we'll do commands like that. So we still do it, but I mean, that's all we had, really. First time I saw a computer, that's all we had. That's as helpful as it was. Not very helpful, right? You have to know all the commands. There's no mouse. That's computers before 1985, 485, right? When they introduced the Apple Mac. It was all like this. And so that's what we call a command prompt. We still have it. You see here on this computer, it's still there, because we can still use it, especially for some networking commands, one of which I just showed you there. All right, so that I think you'd agree that this is a lot easier, right? Me moving my mouse around the screen and clicking on things, that's a lot easier than remembering all the commands and typing them in and having a lot of stuff. That was a little bit, some people found it kind of fun, and it's still around because it's still efficient for doing networking tasks. But that was computing until 1980s. All right, so when I say that was computing, the word computing is older than computers that you know about. So how's that possible? Because they used to have people that used to sit in offices working for business people who used to add up all the numbers, right? Pretty important job, because, you know, if the numbers are wrong, then the amount money's not counted right, and somebody's going to lose out. So that's pretty important job. And they used to call them computers. That's a person adding up things. So nowadays, I guess you'd call them like a junior accountant or something. But yeah, they were computers. But now let's be a little bit more modern about it. What is computing? It's we do calculating, determining things. We do use a lot of mathematics in computing, but you don't have to. I mean, you have people that work with computers a lot, and all they do is draw pictures. You know, they make anime or something, you know what I mean? Or they play on social network. So it can be very mathematical, and that can be very satisfying, or it cannot be. It's up to you. So computer science, on the other hand, is a branch of engineering, as it says. Engineering, so using computers to solve problems. I guess this is the broad definition of engineering, where engineering is using some kind of science knowledge to solve problems, to make something to solve problems. So you could have a computer engineer who actually designs and builds computers, or you could have a computer engineer who we'd call a software engineer, who actually designs computer software. Actually, we got a couple guys on our staff who have degrees in computer engineering. Right, so the abacus, Chinese used it. Lots of other people from not so far away from here used it, right? So Afghanistan, and some other places. So it's been around for a while. Nice way of doing. If you've ever seen anybody using it, they can do their calculations quite quickly. And yeah, so it was a great little invention, that one. But more recently, we have these people that went and did these kind of inventions. These are little machines. So when I say machines, I don't mean a machine that's got an electric motor or an internal combustion motor. I mean the actual energy required to make the machine work would have been human power or something like that. You'd be turning some knobs or something. But the thing is that they would have gears that would work kind of like a clock, right? So a clock is kind of solving a bit of a mathematical problem, isn't it? You know, to get the hands in the right place at the right time. There's a little bit of mathematics involved in that, and so that was what these were for, right? So if you used some gears in this, you could do multiplication and addition, and maybe even some division. This guy Leibniz, he had his own little special machine. Now I like to mention Leibniz because he was a German mathematician who, you guys are studying calculus, right? So the person who is credited with writing the first book about calculus, so discoverer of calculus, if you like, or inventor of calculus, whatever you want to call it, Isaac Newton. You've heard of him. Isaac Newton, Sir Isaac Newton. When he was about your age, he was at, I think it was the University of Cambridge. It was either the University of Cambridge or Oxford, but I think it was Cambridge. And what happened is, guess what happened? They had a pandemic. Go figure, right? They had a pandemic, and they closed the university for like 2 years. And so Isaac Newton got a holiday for 2 years. not a holiday. So what did he do? He sat at home and did nothing, right? Well, they didn't have social media there, so he couldn't go spend all his time on Facebook, and they didn't have Anime or any of those things. So what did he have to do? Well, he invented the calculus while he was sitting at home for a couple of years. He invented the calculus. But at the same time, over in Germany, there was this guy called Leibniz, and he invented the calculus too. So I don't know how much they talked to each other about it, but they both kind of invented the calculus. And you're going to be learning calculus, differentiation, and integration. Mentions here Blaise Pascal. So we had all these really, really cool sort of mathematicians who were coming up with really cool things during that time, and which relate now to our computing. Blaise Pascal, I'll talk to about him a little bit more in a minute too. The Jacquard loom, the idea of a loom is that you can put sort of fibers of cloth in two directions, 2 dimensions, and then you can make a weaving. And so, you know, you pull this device across it and pulls the strings in the right place so that you get the right pattern. Kind of like rug making. So you could use it for making rugs, or you could use it to make any other sort of cloth. And, you know, it's kind of a big job. And people have been doing it for thousands of years, really. So like the Greeks were doing it a long time ago, etc. Now, Jacquard, he sort of figured out this idea that, you know what, if we had some kind of card and we punched some holes in it, it could give instructions to the loom so that we could design a loom that could work with a card, and the card could be a way of giving input of where to put the strings so that we could sort of automate that process. So it could make the weaving a little bit more standardized and maybe a little bit more faster. And so he came up with a loom which used cards. And then Charles Babbage, he came up with a machine which was able to do calculations. So we already talked about some of those, but this is what his machine looked like. And so you see there's lots of gears in it. And so basically you dial some things around to get some numbers. And then depending on which cranks you do, you're either multiplying or dividing or whatever. So you can put equations into it and get an answer out. So that was kind of a cool idea. And then there was this lady, Ada Lovelace. And she's referred to as the world's first programmer. So basically, she came up with a way of putting together an algorithm, I guess you could say, a way of solving a problem by a series of steps that we could use with these analytical engines that we've got. And so she was looking at like this device and saying, well, how could I use that? Maybe I could write a little program to make it work, right? A series of steps of how I could make this thing work. Now, it's not like an electronic computer that you got an interface, you know, with, like we've got, but, you know, you'd have a bunch of steps, which would be turning little levers and stuff like that to make it work. And she was sort of came up with that. All right, so then we get to Hermann Hollerith. Now, the cool thing about Hermann Hollerith is he's a great example of how computing solves society's problems, I guess you could say. So this is, it's a little bit of a mathematical problem, but it's really a social problem as well. So the United States, very fast growing country for many, many years in the 19th century. So that's 1800 to 1900, very fast, lots of immigrants coming, especially from like 1850 to 1920, lots and lots of immigrants, like million a year kind of thing, right? So, I mean, the country was empty. Oh, not empty. Okay, so there are people there, but well, that's a kind of a sad story that I probably shouldn't mention. It was made to be empty. And so a lot of people sort of poured into it, but they didn't know how many people were there and didn't know where those people were. The way that we find that out is you do a census. And so you may have seen census here in Qatar. I mean, I've had a couple of censuses since I've been here. There's one like last year. Somebody comes around and wants to know how many people in each house and lots of other things about those people. And so that was happening in the United States, and all of that data was being collected. When they first started doing this, it would take them 10 years to do it. They do a census every 10 years. When I say take them 10 years to do it, take them 10 years to collate all the data from the census. So Hollerith came up with this idea, you know, hey, you know, this Jacquard guy, he had these, he used these cards to program this loom. Maybe I could use something like those cards as a way of collecting data, and we could sort of run those through some kind of machine and use it as a way of summarizing all the data. And so actually doing that, he was able to speed up that collection from like 10 years to 1 year. So that's quite a big and impressive thing. Now, in this picture here, we see a lady who's working with a reproduction of the kind of input device that was used for Hollerith's machine. So they're inputting the data on the census that's ending up on a punch card. And then those cards go into a sorting, and basically, depending on where the holes are in the card, those represent numbers and other data. And then that can be used to compute the total number of people in various categories for the census. Now, that's the start of IBM, because Hollerith's idea really launched this company, International Business Machines. And we see this card, these cards, this would be common, as it says, from the 1928 to the early 1970s. When I first went to university, we used cards that did look like that, except we didn't have to punch holes in them. We could just use a pencil and cover the numbers to make a program. So they were using cards well into the 70s, and I've actually used them. So, but they were being used, the IBM one was being used like that. So IBM was a big company that was sort of took Hollerith's idea and used it to solve business problems for the government. And so, yeah, there we go, from 1896. IBM is still a big company. It's been sort of, at one time, IBM was like Apple or Microsoft. You know, I mean, at one point, IBM was like the world's biggest computing company, and that's not that long ago. I mean, I remember when IBM was the world's biggest computing company, like until about 1980 sometime. And so in those days, and what did IBM do? They sold, we say they sold iron. Basically, they sold big computers, and they sold them to governments and big businesses and things like that. And so now the biggest company in the world is what? I mean, last year it was Amazon. Now it's like Tesla or something like that, right? And, you know, before that, it was like, was it Google? Was it ever Google? I don't know, Apple at one point. It was Microsoft at one point. So we see this evolution of the computer industry where it's sort of changing from the focus being on iron, you know, IBM. IBM now is still a big company. They're not selling lots of big iron mainframe computers. What they make their money out of mostly now is out of providing sort of, how would you call it, consulting solutions to people, to their business problems. So they've actually changed what they do quite a bit to stay alive. All right, so if you're interested in what some of these big iron computers look like, that is one. And the Harvard Mark I, which is an IBM. So a single computer there that takes up a lot of space. You know, you'd have whole buildings just to hold these computers. And to be fair, I bet my computer that I've got here, this is a computer. I'll bet that got more power than that thing that you're looking at there. I bet it does easily, right? I know this has got more power than the first desktop computer that I ever used. Yeah, I mean, you know, what do we got? We got processors here that are working at 2.4 gigahertz. A hertz is a cycle per second. When I first started working in computing only 30 years ago, right, we didn't have processors on mainframes that worked that fast. You know what I mean? So, wow, computing is just, it's awesome. And so I'm running out of time. So what I'm going to do is I'm going to relaunch this meeting. Why does it, I hate how it runs out of time. I don't want to upgrade because then I have to pay money. So what, do you guys want to take a break? Because we're running out of time. That means I've been talking for a long time. It's actually, according to my watch, it's only been 35 minutes. So yeah, I'm going to stop this and we'll take a break for a minute. Is that all right? 5 minutes? Is that all right? Will you come back? All right, let's take a break for 5 minutes and then we'll continue on for a bit after that. All right. So I'm going to stop this. because I run out of time. What I will do is I'll launch the meeting again